So just to be completely fair, so everyone knows before I read this, I am sponsored. This is one of my sponsors, is Terso. They did not ask me to read this or anything. I just saw that a huge amount of people on social media were talking about this. It looks really, really interesting. I've known about this for a while. In April, I was trying to convince them to at least reasonably look at Zig before they just go into writing the Rust one. And Pekka, the person who wrote this, did actually try to build out this first version with Zig. So I thought that was pretty cool. He does write about it. He jokingly called the private repo Ligma instead of Limbo, just so he could make a joke at me. So that was pretty great. This is not hashtag not sponsored. I get zero. I'll get $0 from this. Anyways, 2 years ago we forked SQLite. We were huge fans of the embedded nature of SQLite, but longed for a more open model of development. And for those that don't know what that means, SQLite, there's only 3 people that maintain SQLite, and you effectively can't have any sort of commit into it. Also, the testing infrastructure and how SQLite is tested, I believe, is also closed source or hidden behind some sort of wall where you can't see. So you actually don't even know how it's tested. So you can you can't make changes, and you can't understand how SQLite does the changes. SQLite code of conduct based, but their development process is a little goofy. libSQL was born as an open contribution project, and we invited the community to build with us. I thought this was a good move, by the way. And libSQL is actually now more GitHub stars than SQLite, which is crazy to think about. As a result, libSQL is an outstanding success with over 12,000 stars, GitHub stars, 85 contributors, and features like native replication and vector search. libSQL is the engine that powers Terso platform. Today, we are announcing a more ambitious experiment. What could we achieve if we were to completely rewrite SQLite in a memory-safe language, Rust? With a Limbo project is now available right here. So you can actually go check it out. They've actually done really, really well, I believe. It's taking off quite a bit. And it has a lot of features that are kind of interesting that it's very, very hard to have when it comes to SQLite today. The pros and the cons of forking. When we forked SQLite, forking was not the only alternative. We considered rewriting it entirely, but we were concerned about the huge lead time needed to have something production ready and the toil involved in keeping compatibility. A fork would also allow us to keep back merging from SQLite, adopting new features as they come. By the way, this is really, really smart. This actually lines up pretty well with Joel on software. If you don't know the Joel on software approach on software, not invented here. This one. It's actually this is a really amazing take, which is you should invent the things that are critical to your business. Joel on software, yeah, this is actually a really great take. And so it's just like, why, and he talks about this whole like Microsoft team that's by itself that doesn't adopt any other Microsoft technologies, and they just build. And why are they good at doing this? It's because they build everything for themselves and they're moving fast for themselves, and that's the only purpose. And I think that this falls really good with this one, which is Terso obviously being distributed SQLite. To be able to have this kind of like serverless, edgeless style SQLite. You can use SQLite for a very long time to kind of get it up and running, but at some point, you're going to need it to be able to do what you need it to do, and at some point, you just have to rewrite it and say, no, this is the one. This is our business. We need it to be the way we exactly need it because we need to be able to hand tune it to precisely what we want, and this goes from being a liability to becoming an asset if they can do it well, right? That's also assuming that they can do all of this, right? On the other hand, there are disadvantages as well. SQLite's test suite is proprietary, meaning that it is hard to achieve the confidence to make very large changes. It is also written in C, an unsafe language, which makes evolving the code base with confidence even harder. Weighing the pros and cons, forking was the way to go, and the libSQL project was born. A new approach. Adding vector search to SQLite was an eye-opener. We didn't want to do this as an extension, since we wanted to make the syntax as straightforward and natural as possible. That would require changes to the bytecode generation, which we did. We were able to expose vectors as a data type, relational query and vector data together in the same table, as long as the query doesn't need an index. Use perfectly boring SQL syntax. But the searches with an index without making very invasive changes, it was hard to achieve the syntax we wanted. Here's a little this, and we ended up settling for this. All right, so this is what we wanted. This is what they wanted, but this is what they got. From movies, order by vector distance cosine, vector top k, this, movies, outer row equals this. Okay, yeah. Close. The index is represented as a separate table, and we have to explicitly join it with the main table. At the point, we decided to try a new approach Let's see, and answer the question. How much effort was it really involved in rewriting SQLite from scratch? And can we do it in a way that effortlessly keeps compatibility? Would that make it easier for us to be more aggressive and do some things we wanted to do in our fork, like asynchronous IO, with a high degree of confidence? To answer these questions, Pekka, by the way, that's the CTO, started an ambitious experiment on his personal GitHub account. It was named Limbo as a code name temporarily, and it did extremely well. Without much press, just me talking about it on X, the project grew to 1,000 GitHub stars and attracted more than 30 contributors organically. Yeah, because I didn't what's it called? I didn't like go over this topic or anything. It was purely like an organic growth, which is pretty amazing, by the way. With success of this experiment, we decided to turn Limbo into an official project at Terso. It is still an experiment, but now an official Terso experiment, which will allow us to pour more resources into it, including more time the other engineers in the company. Our goal is to build a re-implementation of SQLite from scratch, fully compatible with at the language and file format level, with the same or higher reliability SQLite is known for, but with full memory safety and on a new modern architecture. That is not to say we're building a competitor or alternative to libSQL. If it succeeds, this code base just becomes libSQL. The code is available under the same license libSQL, MIT, and with the same community-friendly attitude that defined our project. It's pretty wild, right? Like a modern-day rewrite of a database is pretty wild to see. Can we match SQLite's famous, world famous reliability? Since this is a re-implementation, does that mean the testing is now even harder? The reality is that it is the other way around. Since we are re-implementing it from scratch, we are doing deterministic simulation testing, which, by the way, this is super cool. I love this stuff. So this is where I kind of started going with some of my projects, which is how can you test your product over and over again and see if it works without doing a lot of work, without writing like every single case yourself, but instead making something that like happens automagically and it just goes and it keeps on happening. Now, the harder part with anything to do with like SQLite is that there is file reads. There is all this stuff that happens behind the scene that makes it very hard for it to be deterministic, right? Because you can't just like ram a bunch of stuff through because things will just happen at different rates then. You could run the same simulation twice and it won't result in the same ordering of things. Built in from the get-go. We have both added DST facilities to the core of the database. We partnered with Antithesis to achieve a level of reliability in the database that lives up to SQLite's reputation. Apparently, they launched their new version and they've been working with it, and word on the street, or the things I've read, they've only had 2 bugs found so far from the community, and both were considered in like the minor, right? It wasn't some large overarching super problem. It was just like, oh, some really kind of small corner case, and now they've added it to the determination. Like they've helped influence their deterministic simulation testing, and now that's also covered. And so now it just keeps on going. So it actually sounds pretty cool. Deterministic simulation testing is a paradigm made famous by the folks at Tiger Beetle. By the way, very, very cool stuff. If you have not seen it, this was like one of my favorite talks of all time was Tiger Beetle. Absolutely amazing what they do. It's like absolutely amazing. That we did at Terso already dipped our toes into the server-side code. With DST, we believe we can achieve even higher degree of robustness than SQLite, since it is easier to simulate unlikely scenarios in a simulator, test years of execution with different event orderings, and upon finding issues, reproduce them 100% reliably. See, that's the big thing, is being able to do that. I think I figured out how to do that with my my game Caleb. So I actually have inside of here, I actually have my main.js. I actually have built into it simulation testing. And so I can actually do this, and I create a reliable simulator. So I do the random number generator. It's a Mulberry 32. And what it will actually allow you to do is create it such that it can actually render the canvas or not render the canvas. And it can run this. It can run the game, and whether it's rendering in a canvas or not rendering, every single frame is reproducible. And so even at the 10,000th frame every single time, all the movements and everything produced will end up in the same position every single time. And I've actually found 2 bugs this way so far, which is pretty crazy. So I can run it headless or not headless. Yeah, it can be headless, or it can be the full thing. And it's been shocking how fun it is, because I find these weird bugs. Like the bugs I found were ones I would not have found, and it would have been really hard to debug because people would have just handed it to me and I wouldn't have understood why it was happening, right? And so instead of running unit tests, I just did reproducible deterministic testing, which is it was super fun. Let's see in the world of DST, or in the DST world, writing our own simulator is akin to writing unit tests. They allow us to move fast, experiment easily, and stress changes thoroughly. But much as unit testing does not do away with the need for higher level integration testing that tests the behavior of a system at a higher level, we felt like we needed to go the extra mile to achieve the levels of reliability we wanted. To complete the puzzle, we wanted to deterministically test the behavior of the database when interacting with the operating system and other components. To do that, we are partnering with Antithesis, a company that provides a system-level deterministic simulation testing framework. By the way, I was actually going to have someone from Antithesis on the top shelf, I believe, or at least talk to them, because this is kind of crazy to think that you could produce a deterministic simulation testing framework as a company. I'm a bit confused by that because this sounds pretty cool. I don't know. I just liked this whole idea, and I want to know more about this Antithesis company. I have no ties to them. I don't even know who they are, but it just sounds really neat. On the top shelf? Yeah, potentially on the top shelf because it's just super cool. We just reinventing the wheel? Yeah, yes, it is okay to reinvent the wheel. You know, like I hate to break this to you, but wheels 100 years ago sucked. Reinventing the wheel is like a really good thing, generally speaking. We should constantly do this. Is this some sort of Chaos Monkey? It's kind of like Chaos Monkey. A Chaos Monkey is a form of simulation testing, but it's almost like the anti-simulation testing. Instead, it's like it's to force the creation of unknown behavior and to ensure that your service continues to operate well, if that makes sense. So instead of just simply being, so for those that don't know, Chaos Monkey, so typically there's 3 levels. There's Chaos Kong, Chaos Gorilla, and Chaos Monkey. And this usually involves microservices. So Chaos Monkey is an individual machine. And so what Chaos Monkey does, and this actually runs at all times in Netflix, every single day, I don't even know how many services experience Chaos Monkey, but lots of services do. So every single time a Chaos Monkey strikes, it just kills a machine. That's it. It just kills a singular machine once. Chaos Gorilla will kill an entire service. So it's like, hey, this service in this region just disappears for some amount of time. Like everybody else should be able to handle the situation in which this service in this region goes down because we want to do this. And then on top of that, then there's Chaos Kong, which is an entire region like US West just disappears. And this happens pretty regularly at Netflix. Like this happens all the time. It's a super cool way to test because what you're ensuring is that the world, no matter like a lot of things can go wrong and Netflix continues to operate well. The only time it doesn't keep working, in prod, of course. It happens in prod. You couldn't test it any other way, right? It'd be crazy to try to test this not on a prod because you wouldn't get all the goodness coming out of it. Chaos Godzilla would be just simply to turn off the internet for the world, which I don't think that works. Let's see. It can simulate all sorts of hardware and software failures. Antithesis does this by providing a deterministic hypervisor that runs many fuzzing threads in parallel, allowing us to quickly search the input space. As an example of why this is important, they have already helped us find an issue in IO Uring implementation under partial writes. Our own DST framework would not have caught this. Since the actual IO loop is replaced by a simulated IO loop in testing, partial writes are an extremely rare condition, and therefore hard to test in an automated fashion. Yes, I assume what they mean by partial writes is that when you attempt to write to a file, you can only write so much of the data to a file. And it's like, oh, sorry, you tried to write 50 bytes, but we could only write 30 bytes due to some buffer somewhere is not ready for more data, and that's just that. Aside from the deterministic simulation testing, we also routinely fuzz inputs and then make sure that the generated bytecode is the same for both limbo and SQLite. The current status. While Limbo is still in early stages, it has already achieved some important milestones that are already a couple of things worth noting. Fully asynchronous IO. Limbo is designed to be fully asynchronous. SQLite itself has a synchronous interface, meaning driver authors who want asynchronous behavior need to have an extra complication of using helper threads. Because SQLite queries tend to be fast, since no network round trips are involved, a lot of those drivers just settle for a synchronous interface. However, this has 2 fundamental problems. Not all SQLite queries are fast. Facts on facts. Aggregation over large data, for example, will always be slow, even if the data is fully local. In modern environments, it is actually desirable that queries go over the network. One example is Terso, which serves SQLite over HTTP. Another example are implementations of SQLite over S3, providing the illusion of infinite storage space, where data can be cached locally, but parts of it may be remote. Or you can imagine this in almost every situation. How many phones have some form of of SQLite in all applications? right? Like they just simply exist. And so of course, you're going to always want some level of remote data, local data, and how to like manage those two different things. That's a crazy hard question. This, by the way, this is why I said if I were to get a real job again, I would love to work at this specific place, because it's like these are problems that I would find exceptionally fun to go and solve. Limbo is designed to be asynchronous from the ground up. It extends SQLite 3-step, the main entry point API to SQLite, to be asynchronous, allowing it to return to the caller if data is not ready to consume immediately. On Linux, Limbo uses IO Uring, a performant API for asynchronous system calls. Designed for WASM. While SQLite can compile to WASM, it is mostly an afterthought for SQLite. In practice, projects like SQLite exist to extend SQLite and allow it to function in WASM environments like StackBlitz. Limbo is designed from the ground up to have a WASM build and already has an VFS implementation that works with popular tools like Drizzle without any changes. For example, it is possible to write from Drizzle, import as Drizzle, import database, new database, Drizzle, SQL table, select, result. In a browser, let's see, browser support is in the works. That's pretty cool. Okay, hey, that's pretty cool. And I think hopefully everybody knows Drizzle, the most unhinged Twitter dude. They're like FFmpeg level unhingedness. They're crazy. They're crazy. They are. You know they are. SQLite is known for its stellar performance, but in many operations, Limbo is already on par or faster than SQLite. Executing cargo bench on Limbo's main directory can compare SQLite selecting star from users limit 1, 620 nanoseconds on my MacBook Air M2, with Limbo exceeding the same query at 506, which is 20% faster. By the way, this kind of stuff you should just, I will straight up say you should just ignore this. I don't think this has any value yet because they're not 100% compatible. And so until it's like 100% absolutely the exact same thing every single time, then and only then should this be ever attempted. And not only that, but you should really be testing also like the limits, not a singular query, because often your problem is never just one query that one time that's really, really fast. You're never worried about the 620 nanoseconds versus the 506 nanoseconds. What you're almost always worried about is when you get like thousands of connections all attempting to do one thing, and then therefore you start getting this weird 99 percentile that's like 1 second or 2 seconds, and you're like, what the hell's happening now? Why is there this just giant spike in our latency? There you go. That's the problem. Let's talk about that problem. I want to measure that problem, and I want to see how fast or how slow Limbo is in comparison to SQLite. That is 1,000 times more interesting in my book. Right? Yeah, it's 420 versus 420.1 FPS in gaming. It's just like, oh, cool. Cool, dog. Like, that's cool. Dude, your menu renders at 5,000 frames per second. That's crazy. Wow, Call of Duty. Your game must perform really well also. Simplicity. Despite the fact that SQLite's file-based nature makes working with it extremely simple, SQLite grew a considerable amount of tunables over the years, which make getting top performance out of the box non-obvious. Yeah, I mean, even just making multiple calls to it is non-obvious. You start getting all these failures because you don't know about, like, the wall, right? You don't know about all these like extra things that you got to start thinking about, and having it not fit. Like, you have to actually think about quite a bit to get SQLite up and running. The SQLite numbers on the benchmark above are after tuning. For maximum performance, users have to choose wall mode over journal mode, disable POSIX advisory locks, etc. See, I never even did this. I never disabled POSIX advisory locks. I didn't even know that was a thing. Limbo, while maintaining compatibility with SQLite's bytecode and file format, drops a lot of these features that we consider less important for modern environments, including SQLite's amalgamation, the build system that generates a single C file, providing a better out-of-the-box experience. Are you interested in learning more? Limbo is available under MIT license on our GitHub. If you're interested in building an embedded database with the bold vision of taking promises to SQLite to the next level, come build with us. Pretty cool. I'd say pretty cool stuff right here. I like this. I think it's pretty interesting. I am curious about the code. One day I want to actually look at the code and actually go through it and see like how complicated is it writing all this? Because I mean, at the end of the day, it's a bunch of cargo, right? And whenever you do a bunch of cargo, things can get a little bit. It can get a little bit intense here, right? You're gonna have to. I'm curious just how readable and how great this all actually is. Look at all this extern C unsafe. Look at all that. Oh, it's so unsafe. Anyways, is Limbo just a rewrite of SQLite in Rust project? I mean, it's a rewrite along with other things, right? So it's not just a rewrite. That's the thing, is that to call it a rewrite is not quite fair, because it's attempting to add features that SQLite just doesn't have and attempting to focus on more of the async performance side of things, as opposed to just saying, hey, it's just syncing fast enough, right? Instead, it's like, no, actually, I actually want to make this. All right, anyways, so kind of more of a riff on SQLite rather than a one-to-one rewrite. No, it's a one-to-one rewrite. It is definitely a one-to-one rewrite, but it's also going to be with more stuff. So it's going to be SQLite plus more cool stuff on top of it. So SQLite plus, right? And so it's unfair just to be like, it's just SQLite. No, it's SQLite and hopefully more things that are modern and good. So here's the deal. I'm going to end this. By the way, hey, the name is, again, you wonder why I think this company is so cool. I think they're doing all the cool stuff. I love this idea. By the way, deterministic simulation testing is like the coolest thing in the universe. You should really attempt to see if you can make something that does it, because you can find so many cool bugs. Like I said, with my little game, with my little simple tiny game that I was making, I found just such weird stuff that I did not know even existed. I had no idea that this stuff was going to exist. When let's see, Firefox. For those that are wondering, let's see if I can bring this up. Yeah, not now. Localhost 3000. Like, one of the things I didn't realize that was going to happen is, see, we're working on getting the graphics up, okay? Here's my little guy, right? And so if my little guy were to fall out of the bottom, but then jump up right as it was into the next row down here, I would do a search for letters to see if there's any letters. And if there's no letters there, then I can't do any sort of letters. Like, I can't go like FX and jump to the next X. But if I were to execute that one level below, it would actually completely crash the game because there was no row there. And I just had no idea that existed. And so it took a while for me to realize that was like a thing, that existed. By the way, that's a portal. Did you just see that sweet portal? I just made this portal really, really big. I want to find a way to make it so it like slows him down while it's falling through. I have some fun ideas. I want to be able to make this so that it's like light blue and kind of translucent, so we can actually do a cool shader of the thing going through it, and then you like slow down and slow person for just a moment. I think it'd be a lot of fun. Okay, you sent me the one thing about the rules for the programs. Yeah, I did actually want to read this, because I think terminals are insane. Terminals are crazy. Anyways, the name is the Primogen.